Greetings. Welcome to our presentation on the exterior finishes for wood light frame construction. Chapter 6 in our Allen book and the second presentation of our 5th week. This is a gorgeous image here from, if you're not familiar with James Cutler and his group's architecture, just beautiful expression of the wood frame, the skeleton of the building, and beautiful finishes as well. Just gorgeous work. Recommend you take a look. So today we're going to cover, we're going to talk about the envelope of the building essentially, and what we do to keep water out and keep the warm air in and the cold air out in the winter. So we're going to talk about a lot of little technical pieces, kind of how they close up and make this envelope weatherproof. So quite a bit of vocabulary, and then we'll have a quick survey of some siding and roofing types, but we're more interested in the technical details here and the components. Okay, so protection from the weather, the purpose of keeping water out of our buildings essentially. So the structure is closed in or made tight to the weather as soon as possible so that the interior work can begin. This is during the construction process. Roof underlayment is installed first to provide temporary protection from the rain until its finished roof is put on. So here we see our roof framed in, and then the tar paper is put down here, or the roof underlayment. It's often a tar-based, kind of petroleum-based tar product. So it goes by tar paper with when speaking to tradesmen, essentially. Underlayment is the word that we would typically use for it. So that's laid down first. The bottom, they start at the bottom of the roof and work their way up like fish scales so that the water sheds down. And then the drip edge here is put on the side, protecting the edge of the, this would be your rake board. The rake board. Okay, and then the wall moisture barrier is what we see here in the back. We're going to talk about all these in more detail. So here's the roof underlayment going on. So as I said, often there is a piece of like a self-adhering, a stronger underlayment that protects specifically for moisture and ice down here at the gutter. Ice shield is often called. So that's adhered down first, and then the roof tar paper, the underlayment, is being put up piece by piece. And here it's being put up with a really generous overlap. That's a particularly generous overlap. Typically, if it were a 3-foot roll, you might overlap 6 inches. But this is really very generous with this 50% overlap. And then you can see the carpenters installing it, or the roofers installing it here, so on the toe board. And again, a very seemingly, I'm not sure if this is its final resting place, but right now they're overlapping a real lot. So this might get pushed out or pushed up after it's completely rolled out. Okay. Yeah, and this points out that some new synthetic fabrics are also being used. That's what we see here, rather than the tar paper version. All right, and then the walls are covered in a moisture barrier, also known as weather barrier and some other names. So typically the framing, again, that exterior sheathing wraps the entire building. And then the way that I've typically seen it and done it myself is that the plywood sheathing is completely finished, then the tie-back is completely finished, and then when the windows are ready to put in, then they will cut out the holes at that point and install them. So it's sheathing, the moisture barrier, followed by the windows. That's, I think, the smartest procedure. Okay, so here, so typically more and more now we're seeing this tie-back kind of paper, but in the past, sometimes tar paper was used on walls as well. So these like kind of oversized button cap nails there to hold them on. In general, the purpose of this is to keep the moisture out and also helps reduce leaks. So, in short. Okay, moving on to, so that was really just briefly on the envelope there, just kind of covering it up, doing the building paper at the top, and then the tie-back or the moisture barrier on the side. So that was really kind of just after the framing, the first step for making it a little more weather tight. Now we're moving up to roofing and finishing the roof. All right, so first we need to talk about some vocabulary, and we didn't go over roof framing too extensively with the framing. We did the platforms and the walls a little more extensively. So here's our walls coming up. There's our double top plate. So gable end studs. So underneath the gable, we have to complete that, and that's what we see there, the wall studs. This is the point I wanted to point out here, the fly rafter or the barge rafter. So we have our common rafters coming down. They're leaning on our ridge board as we discussed, and then they're cut down here. And at the bottom, the sub-fascia board is connecting them together. But then to get an overhang here at the gable end, we have to put on a fly rafter or a barge rafter. So this is one of two ways to do it, common two ways, is to have this cantilevered pieces coming out, and then they're putting on the fly rafter. Another is just to put it on so much kind of without the cantilever, essentially, where these kind of short outriggers just do it. So two different ways. Okay, but wanted to talk about the fly rafter in particular. So here we are, now that we've got the roof up, now we've got the framing. Now this is just an overview of the different roof pieces. So here we are at the bottom with our rafters, followed by our sheathing, followed by our, so here at the bottom of the sheathing, is that ice and snow guard that I was referring to. So typically that's just at the bottom, one course, you would call it a course. So this is one course at the bottom, and then that's followed by a second course, followed by a third course. So the ice and snow guard across the bottom, and then the roof underlayment or tar paper would follow that, and then it would be followed by your roofing material, whatever that is. Let me just run around and see what the other pieces are. Rafters, so soffits, that's the horizontal piece underneath the roof overhang. The frieze board is the piece that's tucked underneath there. That's not of interest to us today. This is an important term, the rake, right? The rake and the fascia. So the fascia is the horizontal member where the gutter would hang, and the rake board is the incline member. So here we are running around with the fascia to the fascia to the fascia to the rake and to the rake. All right, so when we look at details, we have to know that terminology. All right, so that's all of the terminology across the bottom. This is a hip roof as opposed to a gable, so this is the hip where the roof meets the roof. Then some chimney flashing, and the valley is the kind of the inverted hip. This is kind of like a positive piece, and this is kind of a negative piece, but they're kind of framed in a similar fashion. Okay, and then up at the top we have a ridge vent, and we'll see some images of that, some close-ups, and you talk about the importance of ventilation in the attic. All right, and then just one more close-up of what's going on at the bottom. So this is shingles. I'm not sure what shingle material this is, but again we have our rafters coming down, and then we would have our roof sheathing. That would probably be here, and then that would be followed with a drip edge. I'm not familiar with the furring strip version of this, but I guess to get the gutter out a little further, they put in a furring strip, and this is the flashing or the drip edge that comes across the bottom and protects this area. This area is very vulnerable to water and ice. So this is really kind of like at these junctures, these connections, that's what we're really trying to protect where it's vulnerable. So the drip edge comes on, and then we start with the ice and the snow and the tar paper, and then we have our shingles coming in. So there's a pretty good looking image of that. All right, so now that we've seen it in illustration, three-dimensional illustration, we could look at it as call it an architectural drawing of sorts. There are no numbers on it, so it's not really a construction document, but looking at it as we would see it as a detail section through the area. So here we are at the overhang, so the roof rafters are coming down, meeting that subfascia. Here's the soffit, the horizontal board underneath the overhang. Here's our stud and our top plates, our attic insulation, and again the rafter comes down, subfascia, and that ties back. There's that frieze board we refer to, and our brick veneer. This is what we're more interested in, this top part here though. So then we have our rafter. On top of our rafter, we would have our roof sheeting right there. So that's our plywood, probably tongue and groove or our OSB. Then the underlayment, which is our tar paper, often drawn as a dashed line. And on top of that, we would have our shingles. So we have our sub fascia, that's the dimensional 2x, and on top of that, we would have our finished fascia. And then before the roof underlayment went on, we also have our drip edge, or metal flashing right here. So that's the bent piece that kind of comes and turns there, all going to the gutter. Okay, so we should be able to identify all of these pieces. So drip edge we discussed. The rake board is not shown here. So this is again the fascia. So there's a similar detail we'll look at next that's on the incline here on the rake. So fascia we discussed, soffit we discussed, the horizontal piece, and we're going to talk more about that when we talk about ventilation. We don't see the ventilation strip here, but that's coming. All right, so let's move on to the rake edge now. So the previous one we could see quite clearly where we cut. So the rake, now we're running kind of in line with the rafters. So that's what we see there is our cut rafter. So here we have an end rafter sitting on a wall below, and then the plywood and the siding go right up to it. So there is no overhang here, really. Here we have this generous overhang. All right, and again, I'm just going to flip back real quickly. So we don't see the overhang too well, but right here, if this inclined plane was coming out further, that would be this piece right here. So this is the inclined board. It's a peculiar looking detail. You have to understand where you are in the assembly to be clear. So that's why I'm just kind of emphasizing that. All right, so we're on the incline. So again, here's our cantilevered barge rafter or fly rafter, the lookout. That's the name they use for the cantilevered piece. So subfascia, fascia, or a fascia, not a fascia, I guess here we're calling it a rake board. That makes sense, and just a double rake board for a little more detail. And then a trim board tucked against the house there, and there's the siding. Okay? All right, good. So we will move on from there. And now we're back here at the edge detail at the fascia, and we're talking about roof ventilation. So, roof ventilation, under the sheathing and above the insulation. So sheathing or sheeting, all right, so sheathing is the term that I use, but it's also referred to as sheeting sometimes, which we just saw on a previous slide. So the roof ventilation is under the sheathing, so that is right here, underneath this sheathing, but above the insulation. So there's the insulation. So wall, top plate, drywall. This is our finished drywall. This is our habitable space. Then we have our attic insulation sitting on that drywall. That dashed line there is the ceiling rafter running through. And then we have what would we call this? An insulation bat? Insulation, kind of a guard. I forget the word. It's escaping me now. Baffle. There it is. An insulation baffle. So this would be tucked in down at the cavity here at the end, so that insulation, when it gets pushed down, and we really want to fill up this cavity, but we don't want to block the airspace. So that's why we have the baffle. Then we often have a continuous soffit vent here underneath. So the air is going to come in and then up into the attic, run up the roof, and vent out at the top where the ridge vent would be. That's one version. There are numerous versions and more than numerous, or many different ways to detail this. But kind of the moral of the story is that the habitable space here is enveloped in insulation, but our attic is actually not a conditioned space, essentially. So it's cold. It's cold in your attic. It should be. The air has to move through it. Otherwise, there's going to be condensation and problems. Okay, so that is a short version on roof insulation. And then right here, one other thing they talked about important is ice damming. So especially in cold climates, right here, very, very vulnerable area when the gutters back up and snow and ice accumulate here. That water and ice creep up and get behind the fascia and cause a lot of damage here. So that's an important reason. And a lot of that comes from not having a properly vented attic, essentially. So not controlling the temperatures in there properly. It's kind of immoral. Okay, I'm going to move on from roof ventilation. We'll just look at a couple of quick images of the actual finished product. So here's our continuous soffit vent feeding up air to our attic. Another location could be a gable wall vent, so this would allow air to enter the attic space. And then the air leaves the attic through the ridge vent, which is up at the top of the roof. So the plywood below, so there's plywood sheathing below, the carpenters would cut out a 2-inch, approximately a 2-inch strip right across the top, and then this would bridge from one to the other, letting air out, but keeping, again, moisture, letting the air out, but keeping the moisture out as well, of course. And then some other roof vents, not as attractive. The ridge vent is more effective and hides up there better, but these are other versions. Okay, unvented roofs. So that's all the most attics are vented. Typically they are, but sometimes we have finished space up there, and it's not going to be. So here's a version. So when insulation is positioned above the roof deck or the sheathing, so here the insulation, this is the rigid insulation, that is the hatch for rigid insulation, the checkerboard pattern, as opposed to the here, this is the batt insulation, the squiggling line. So the rigid insulation here is above the sheathing, which is here, and that's, you can see that little tongue and groove sheathing. So this is a habitable space here. There is no attic. So that ventilation is not required when the insulation is above the sheathing. All right. So this is an exception to the rule, or not. This is not the common scenario, but it is possible. And then here it points out recent building codes also allow for an air impermeable spray foam insulation to be installed directly under the roof sheathing. So the sheathing, let's see, the sheathing is all the way up here. Yep, so we have, you can't see the rafter. The rafter is behind this entire thing. So the sheathing is sitting on the rafter, and then all of this would be the spray foam, all shot up there. Then we can see that in the next image here. So we're looking up in between these trusses, and here's the spray foam. So I could definitely see, so this points out here it's more resistant to air leakage, which helps reduce energy consumption. That's great. I don't know, kind of burying the top cords of the trusses up there in something so permanent as this rigid insulation doesn't really appeal to me. And I don't know, I think about like if water ever got through the roof deck, and then it would kind of be hidden behind here. I think if that insulation, like if you had a leak, you could easily take down that insulation and repair. This, I think, would obviously be a mess, trying to take this down and, you know, figuring out if there's a leak appears here, that doesn't mean that the leak, you know, is really there. The leak from the roof could be, you know, a distance from that. And connecting those dots is an important problem, part of the problem when you're working with roof leaks, which are common, unfortunately, or not completely uncommon. All right, moving on. So a quick review of just some of the numerous roofing products that we will find on residential scale wood frame projects. So asphalt shingles, the most common, obviously, inexpensive, come in different grades. So there's always poor, good, and best, you know, so you get what you pay for. There's different products out there. So wood shakes, very attractive. They age beautifully. They're really very durable, but they're prone to damage, you know, if tree limbs fall on them. But otherwise, they are a good product. Concrete tile roofing, so here's the precast elements, probably very durable. Again, tree limbs and cracking could be a problem. And this was probably where the terracotta clay tiles, beautiful. We saw some of those when we looked at the timber frame residence. And finally, standing seam coated metal roofing, very popular, pricey. And this presentation didn't have slate roofing in it, obviously another popular option. All right, let's jump into windows and doors. So right now we have the roof is sealed, and we have our air barriers, our air barrier over the walls, and now let's finish closing in the openings. All right, so some basic terminology when talking about windows and doors. I wanted to throw these images in to discuss level, plumb, and square. So this is, I don't know where this came from exactly, but it's basically telling us if we're installing cabinets that we want to make sure that our walls are level, plumb, and square. So first we're looking for plumb, and here we see a level standing up vertically, and it is telling us how plumb this wall is. Is it perfectly, does it stand up perfectly per our level, or is it out of plumb, we would say. So we want, for cabinets especially, we want plumb walls behind it. So really the woodwork that the rough framers do really has a big effect on the amount of work that the finish carpenters have to do. If the walls are all out of plumb, then it's going to be much more difficult to put the kitchen cabinets in correctly, and then more shimming will have to be done. So then plumb is holding that same level horizontally and making sure that it's perfectly horizontal, or is it out of level? So this is important for windows and doors to be put in level and plumb as well. That's why we're bringing up this vocabulary now. And then, of course, square, when one wall is square to another. So level, plumb, and square are what we aim for. And when it comes to windows and doors, it's a problem when they are out of square or out of plumb. Then they don't work properly. And then this just say that all builders today typically have lasers as well, which will tell them if things are level, plumb, and square. All right, so some more vocabulary talking about the window. So again, I know that this is all very residential, kind of traditional, but a lot of this vocabulary does translate to commercial products, and which we will be looking at, especially in the second half of the course. So some of the vocabulary that we did want to point out here, though, is the jamb. We're going to be looking at jamb details. So up here is the head jamb of the window. So this is the piece that would accept the sash. When the sash goes up, it's the jamb that kind of accepts it. And when you talk about a jamb detail, you're really talking about how the wall and the trim and the window all meet, and how this is all assembled, and how it's made air and waterproof as well. So that's the head jamb. The side jamb would be where the side piece of the window meets this wall, and then how the casing is put on in the interior and the exterior. So the side jamb detail will show us this whole connection. Then we have our sashes, which are the pieces that actually move. Of course, we have an exterior sill and an interior sill. They're calling a stool. The trim piece across the bottom is the apron. Stiles and muttons. You'd probably have to be talking to someone in the window business to really know what that terminology. That's less common. And then rails and sash locks. So these are all the components of a double hung window in particular. But the jambs, we want to be able to locate the jambs for our next details. So again, here we are. So these are 3 jamb details, and every window type that's represented on a set of architectural documents will typically show a head, jamb, and sill detail for a window. So what happens down here, what happens on the side, and what happens on the top. So this actually has a door thrown in, but it's still pertinent. So these 3 do not go together. This is a window sill. This is a door, but again, it has a jamb, a head jamb as well, so it still pertains. And then here we're on the side of I would guess a window, not sure, window or door. I guess it would be probably a door. There's not too much detail. These are like residential, all wooden details, so they're kind of peculiar, a little dated, but nonetheless helpful for us. So just to go through it, let me read through this part, and then we'll get into the details. So, yeah, basically we want to be able to identify the locations of these pieces. where the trim is, where the frames are, where the sills are, where the casing is, and where shims are located, and where the head flashing and the sill flashing. So where all these pieces live, we want to identify. So after we run through these, that should be the case. And then the point of these objects, or these components, really, is again, we talked about having a nice plumb and level, precise frame. So that's the shimming part of it when we have the shim. So again, I said if the rough framing part was out of square or out of plumb, the shimming would happen. That's here, shimming, tapered shims, and that's what we see here, wooden shingle wedges right there. So in this side jamb detail, for instance, we see two studs that are flanking this door, then the door is put in, and again, the rough opening allows for a little bit of space. So this is where the carpenters will put their levels on the door frame and get it to be perfectly plumb. Again, plumb, level, square. So if anything is out, that door is not going to work properly. So that little bit of shim space right there is very important, and that's how the finished carpenters will get it to be perfectly aligned and working and functioning properly. So that's purpose number one, and then purpose number two is also just to stop all of the air filtration. So we have insulation and sealants that are used. So again, coming back to this one, we have the wall, we have our finish on the, I'm not sure, we're probably on the interior here. This would be our drywall, and we have our sheathing on the outside, and then we have some sort of a finish product on the outside. Then the door comes and it gets put in, it gets shimmed, and then we have this vulnerable open area. So that's the importance of this trim, and this trim as well, is to stop the air infiltration or allowing heat to seep out of the house. Okay, so just we'll look quickly at the head of the door. So here's our door, here's the door frame that stops it. So right in here, that would be our area that's vulnerable to air escaping or cold air getting in. So that's why we have our casing here and our interior trim there. And then the flashing part, another important part, right here, head flashing and sill flashing. So this is, again, to keep moisture away, keep water away. So we have our siding that's coming down and almost sitting on our casing, but instead we have this piece of metal flashing that tucks behind it. So if water comes down here, it's going to be pushed around that casing. All right, so protecting from water, another important point of all of this. All right, and then we can jump down here to the window sill detail. I'm sorry, this might be a door sill. No. Yeah, I think this might be a door sill. I was thinking whether this is all door. Yes, maybe this does all go together. In fact, it is all a door sill. I looked at it earlier and I was convinced this was a window, but that's not the case. I think we're on top of a joist here. I think this is floor insulation in the basement. This would be a rim board, I believe. And then we have our floor sheathing here. So we're looking at a wooden door sill, essentially, which we don't see much of at all, but that's where that is. And then it's coming in, it's hanging over that hanging over the rim board. So then there's a rim board, then there's wall sheathing outside, some sort of a finish material, and then a little flashing again. So that flashing would come all the way back here. All right, so then we're underneath the sill. And then here at the base of the door, we have this little rain drip to get the water away from this opening, and then weather stripping at the bottom of the door. Okay, that makes sense. So again, though, the same types of details would be around a window, all just the same. All openings are described in this fashion, and all of these names pertain, really, casing, flashing, everything here except door frames specifically pertains to both doors and windows. Okay, let's move on. All right, so putting in windows now specifically, getting back to the moisture barrier that we put on. So typically, like I said, my experience, and I think it's best practice, is to wrap the entire building in that moisture barrier, in that tie vat. And then when it comes time for the windows to get cut out, or windows to be installed, we cut that, and we have to properly flash. So a nail flange they're talking about here. So a nail flange is the piece that's connected to the window, and it essentially, when we put the window into the rough opening, the flange is going to stop it from falling all the way through, and then it's where we put the nails through the nail flange into the 2x material that's behind it. And then, so the important part is this diagram. And there are a lot of different versions of this, and probably a lot of debate as to the best way to do it, but it's essentially taking the Tyvek, or the moisture barrier, and wrapping it into the window, and then adding this additional kind of fabric, synthetic fabric flashing, so that we properly seal this. So this is part of these details, and I think that's what it says here, actually, right here, important point that I missed. Moisture barrier is omitted from drawing for clarity, but is required for actual construction. That's a note you'll see on all of these architectural drawings, is that it's there, but it's hard to draw a piece of paper, something that's paper. Okay, and one more point from this slide. Looking forward to the next slide, we're going to be talking about moisture barrier. Here, the third bullet points out, and this, you will see this on architectural documents, construction documents. Moisture barrier is omitted from drawing for clarity, but is required in actual construction. So, very important part of the puzzle. The moisture barrier is just too small to draw a single paper, something that's paper thin in this detail. So again, if we are on the exterior on this side of the building, this is our sheathing, so the moisture barrier would be against the sheathing installed right here, and then when this door is installed, it should be properly cut and wrapped back underneath and in. There are a lot of different details for this, but it's an important part of this, and a lot of different opinions on the best way to do it. So here, it depends. I don't know what's really below here so clearly, but again, if we're on the outside, on this side, I believe we're on the outside, the moisture barrier would be coming over the sheathing behind the finished product, whatever that is. So it would be coming here, and then it would get cut and wrapped around this area. Okay, so moving on to the next slide, that's what this is about essentially. So this is reference to a nail flange, so that's the piece that protrudes from the window from the side, so that when we're putting this window into the rough opening, it doesn't fall through. The nail flange stops it, and that provides a little holes to put the nails through. So that's what we see right there. Those would be nailed through the flange. And then opening flashed with, and then it's referring to a synthetic fabric flashing. So this, again, there are a lot of different ways to do this. This is just one that's kind of a pretty clear illustration of a way to do it. So I just wanted to run through the finer points of it. I wouldn't test you on, but you should be aware that there are different versions of this. So here, this is the moisture barrier, the Tyvek. So in this image, it hasn't been installed yet. Some reason they're installing windows before they put that on. Typically, I'd say it's not detrimental, but it's typically, I would say that's kind of out of order. It doesn't really make sense to me. Typically, again, the framers could just wrap it in Tyvek, and then when it comes time to put in the windows, cut it back, and here you can see it gets folded in. The top part gets folded out of the way, but the sides, the side jambs, and the sill are cut and folded into the building and then secured around on the interior. And then here, there's a moldable flashing to be put in as a sill pan. So this is a heavy-duty kind of adhesive. Very careful attention's taken at the corners, very vulnerable areas, so it's turned up and overlapped certain amounts. Then the window is put in, and then I think here we have some seal tape coming around. So after the window's put in, it looks like a piece would be put in right across the bottom, and then we like our things to overlap from the top down, so then the sides are overlapping the bottom, and then the top is overlapping the sides, and then finally this piece is released and brought down and secured. So very important step. going back to all of these those jam details, this is a very important part of that. And here's one in progress. So here we see some moisture barrier, hasn't been turned around the corner like I typically know it to be. And then this sill pan is being constructed, self-adhered bituminous flashing. So that's what that is, and then this has a nice sharp-looking copper pan there. And then from the inside, what we see often. And it just points out here that often, even though we have a pair of double windows, we will have a 2-by in between them for nailing. Important. And then here again, going on, putting trim work in before that moisture barrier is put in, and it says, note the house wrap strips installed behind that will be taped to the remainder of the house wrap. Again, I don't really understand why you wouldn't just cover the whole thing in tie back first, but you know, it's construction, it's an imperfect world, and things go out of order sometimes, but getting that behind it is important, and then I guess it'll be taped together. Okay, so now just a couple of slides remain, and it's a very, very quick survey of siding. We're going to get into more exterior envelope finishes when we get into more commercial size pieces, talking about masonry and stonework and brick. So this is a quick intro to numerous kind of lightweight pieces. So board sidings are very popular, come in a lot of different materials. These are traditional, looks like wood board. So it points out here, note the attachment and overlap design. So here these dashed lines are the attachment nails. Overlap designs are all the different ways that these things are lapped together, again with the whole purpose of keeping water out. So water comes down and then finds that little notch, and then it's not allowed to be pulled back up into the space, but is instead sheds off. So the first 4 examples are normally applied horizontally. So these are different types of, these are just describing that area, the shiplap or the rabbeted bevel. So these 4 are installed horizontally, and that's how we see them here in section. Here normally applied horizontally. The last is installed vertically, so now we're looking down on it. So here we're looking at the side of a stud, here we're looking at the top of the studs, and this is a board and batten. So we have a board that's put in, and then the little battens are used to cover this area that's left for expansion and contraction behind it. So these are vertical members that are installed, and then this type of tongue and groove, I guess, is the 5th, and it's saying that it can be done either way. So as long as it's protected from above, it's safe to be put in either way, where these are installed horizontally. Okay, moving on, here we see it being installed, top to bottom, large trim boards, make it an easy installation. We'll see some other examples where they actually don't put on the trim boards and they let the siding go around the corner. It takes a lot more skill to do it neatly in that fashion. All right, so here we are with the siding, or the corner board, and here we see a really crisp edge with mitered corners, very attractive. Here, Rainscreen principle, and we'll explore this more when we get into commercial products. So here we have furring strips mounted directly into the studs behind, and it creates a little space here behind it. So basically the question is when, if water's going to get behind it, or, it's inevitable, it's going to happen, how's that water going to get out? How do you do some damage control to take care of it? So basically by furring it off, and then the water's, it's not encouraged to come in, but if it gets through, it's just going to fall right through to the bottom, and there's going to be some sort of kind of a drip or a flashing detail that allows it just to drip out, essentially. So screening at the top and the bottom of the airspace prevent, so that's just talking about insects, not letting anything live behind it. But it's a principle that we will look at more closely with commercial products again. And they're similar. Here we have a plastic filament mat here, and it's been installed behind the siding. Again, it provides a space and encourages drainage. So any water that gets back there is just going to be let to just run right through it, essentially. All right, moving on, there's the finished product, or a finished product. I believe it was the same, very attractive looking. And here's another product. So this is an interesting application. So plywood, exterior grade plywood that has actually been scored. So all these cuts. So this is 4x8 sheets of plywood, and they've been scored to create this pattern, which is really pretty attractive. Stucco, a whole nother option. If we have time when we're up with masonry, maybe we could discuss this in more detail. So just going on in different coats, a scratch coat followed by a brown coat. So it's a process. Hopefully we'll have time to return to that. And then panels, so fiber cement panels next to concrete in place, so another attractive option. All right, so that was just a quick survey of some different materials and a lot of technical information there in the middle, a lot of terminology. I hope you enjoyed it. Thank you. But this is that paper, and